Hello, everyone. As Catherine said, my name is Callum Guppy, and for my capstone presentation, I'm going to be reporting on the research project that I pursued during the summer in Haliburton on the subject of assessing the success of group openings in recruiting mid and intolerant deciduous tree species in Haliburton forest. So recruiting mid and intolerant species has become an increasingly important silvicultural and ecological objective for forest managers, primarily for two reasons. One, to rectify the historical trend towards forest simplification and homogenization that's been taking place since European settlement. The scale of this problem has been accentuated by the long-dreaded arrival of beech bark disease, which is causing massive disruptions in the Great Lakes St. Lawrence forest. If the Haliburton case is similar to what we've observed further east, where the disease has already been, they should expect to lose roughly 50% of their mature American beech stands over the next 10 years. And conservatively, the disease will eliminate 95% of mature American beech stems in the long term. And like I said, this is going to dramatically alter the structure and the function of the aftermath forest. I think a great illustration of this is this cute guy over here, the American black bear, which sources roughly 30% of its pre-hibernation diet from beech mast, which obviously comes from beech trees. And that has been linked by a number of different studies to reproductive success during the denning season. So it's important that we promote other mid and intolerant species that produce mast, the only real viable alternatives in the Great Lakes St. Lawrence forest, in order to keep the food web in the Great Lakes St. Lawrence forest viable. So one of the silvicultural options that the Ontario Ministry of Natural Resources has outlined in the silvicultural manual is the group opening. For those of you who are not familiar with this, because I know not everyone here is silviculturally inclined, it can be simply defined as the prescribed opening of canopy gaps less than 2 tree heights in diameter, verbatim from the silvicultural manual. And there is a number of different advantages to this particular system. One, it is single tree selection, STS compatible, which is the main silvicultural regime used in Haliburton forest. It allows for the maintenance of an uneven age structure. Two, at least in theory, it promotes the regeneration of mid and intolerant species within stands dominated by shade tolerance. As you can see in the bottom right kind of schematic here, all that it is doing is creating larger canopy gaps than would normally be created as part of single tree selection that allows the forest floor to receive the prerequisite mix of sun and shade that mid and intolerance need to survive and thrive. How this is implemented, the number and arrangement of group openings is usually discretionary to the forester and the tree marker, but the silvicultural manual recommends that it covers 5 to 20% of the total stand area. A couple of other notes that's relevant to this study. In Haliburton forest is a couple of other common implementation practices. One, they will often retain seed trees of the target species, as in the species that they're hoping to crop within that particular opening. So here's me on a particularly rainy and sad day, standing next to a mature yellow birch. And that means that in this particular opening, they're hoping to crop yellow birch. Two, they will often employ a planned skidding disturbance or scarification regime in order to churn up the soil within the group opening and provide access to the underlying mineral soil, which is a favorable environment for germination of many mid and intolerants, yellow birch and red oak especially. So the current body of literature on group openings is fairly scarce, and there's a lack of scientific consensus. Here is 3 previous studies that kind of show what I mean. Falk et al. Shebeg et al. 2019 studied group openings, the efficacy of group openings in promoting cherry and birch regeneration. And they had very, very mixed results. And even the successes that they did observe was highly conditional on a number of variables. Heinzman and Grahl studied the same sort of thing in oak regeneration in group openings. And they also had highly mixed results with only limited successes. Additionally, with red oak, most of the research that has been done is in the oak hickory forest, the Appalachians. So the applicability of that to the northern hardwood context is fairly uncertain. Another important point to raise from the literature is that the impact that scarification or skidding disturbance I mentioned is greater during snow-free seasons, where the ground is unthawed and there can be more disruption to the soil. So from that, I derived 3 principal research questions to help answer in order to address this particular problem. First, are group openings successfully increasing the regeneration of mid and intolerant species in general, and target tree species specifically? 2, are group openings successfully decreasing the regeneration of American beech, which has a nasty habit of producing rhizomic regeneration that creates dense thickets that suppress the regeneration of commercially and ecologically viable alternatives? Third, how is the recruitment success of red oak affected by season of harvest? This comparison would have been great to also apply for yellow birch and black cherry, but unfortunately there was not enough study sites in order to promote that or to allow for that comparison to take place. So to answer this question, I selected 29 group opening sites from the database that was generously provided by Haliburton Forestry staff that outlined previous group openings that had been implemented and recorded. And I organized those according to target species primarily, but also by season of harvest and geographic proximity to eliminate those potential confounding variables as much as possible. I then established 25 control plots in the surrounding single tree selection matrix around those group openings. Or if the surrounding stand was not harvested according to single tree selection, I established them in another stand nearby that was harvested according to single tree selection and shared similar site characteristics. All blocks were harvested in 2019-2020 operational year. And then I sampled according to the schematic here on the right. There were 4 regeneration subplots, a large center one, usually around the seed tree, and 3 radial ones, 7.5 meters away from the seed tree, 120 degrees apart. In each one of those regeneration subplots, every tree regeneration was identified and counted if it fell within the radius. For statistical analysis, I fitted a linear mixed effects model with regeneration as a fixed effect and plot and subplot as the random effects, and ran a number of ANOVAs, 3 one-way ANOVAs to test for statistical significance in regeneration by shade tolerance, regeneration of target species, and beech regeneration for each seed tree species between group openings and controls. Finally, I also ran a 2-way ANOVA to test for statistically significant interaction between seasonality and treatment type effects on oak regeneration between treatment and control. So for the results section, I know this is a little bit difficult to wrap your head around at a glance, so I provided this helpful table, which should be simpler, that outlines statistically significant findings in this comparison. So as you can see, in both the case of oak targeted sites and birch targeted sites, we did see a statistically significant increase in intolerant and mid-tolerant regeneration and a statistically significant decrease in tolerant regeneration. This almost applies for cherry in that mid-tolerant saw a general increase and tolerant species regeneration was decreased. But there was the one discrepancy worth pointing out is that there was not a statistically significant change in intolerant regeneration. You can see that with those 2 bars there. However, when you break it down to target species regeneration, the trend is significantly less clear. We only found that yellow birch regeneration was significantly higher in group openings than it was in controls. Red oak regeneration was also higher in group openings than control, but not significantly so. And this was rather surprising that black cherry regeneration was higher in the control plots than it was in the group openings. For beech regeneration, a admittedly very disappointing result. In none of the cases did the group opening treatment significantly impact beech regeneration, kind of all over the place. And again, in all cases, beech remained a substantial component of the understory in regeneration community, which is highly silviculturally undesirable. Lastly, red oak regeneration by season of harvest. We found that season of harvest itself was a significant factor in overall red oak regeneration. As you can see, the plots harvested during the winter had much higher regeneration than their fall and summer comparisons, but there was not a statistically significant interaction between season and treatment, as in the relationship between red oak regeneration and treatment type was not affected by seasonality. So, as a summary of the findings, do group openings successfully increase the regeneration of mid and intolerant species in general? Well, yes, except for that one discrepancy with black cherry. But more in specific to that to the target tree species, well, for yellow birch, yes, there's a 13-fold increase, but the data suggests that red oak and black cherry, it does not. Our group opening successfully decreasing the regeneration of American beech. Very, very sad, but no, it did not. At least that's what the evidence would indicate. And how is the recruitment success of red oak affected by harvest season? Well, there was an overall increase in the winter harvest, but there was no significant interaction between season and treatment. So these are actually really, really interesting results. It's somewhat disappointing in some ways, but a number of recommendations can be produced for forest managers in Haliburton. First and foremost, this is probably not a useful tool for combating beech thickets. In all cases, beech remained remained a substantial constituent of the understory community, and by stem count anyway, those plots remained fully stocked. Second, it may be effective for creating yellow birch microsites, but of course, this is only reflecting 2 to 3 years post-harvest. So we would need to have more sampling to see if this trend continues into the long term, if yellow birch actually becomes established on these sites. But they're off to a good start. And lastly, as a general conclusion, this is probably not a silver bullet that's going to effectively prevent or reverse the ongoing trend towards simplification, at least at the landscape level. And especially when you layer on the economic dimension, the amount that Haliburton Forest is paying loggers to implement these group openings, it's rather expensive for having extremely spatially limited results that are also fairly uncertain for those other 2 species other than yellow birch. So as a couple of additional considerations for Haliburton going forward to tie things off, as providing being able to conduct a seasonality analysis for yellow birch and black cherry going forward would be great if that could happen in the future. As I mentioned, there was just a lack of eligible study sites and not enough replicates in order to support that comparison. But as more group openings are implemented and recorded, there probably will be enough in future times for a future intern maybe. Second, the data, it's important to keep in mind that this data only reflects a snapshot in time. It's 2 to 3 years post-harvest. And it's very difficult to make any sort of conclusion about how this is going to translate into adequate free-to-grow stocking. Again, in this, we'll need to perform more sampling further on down the line to see if this trend continues. And lastly, because this study only occurred during 1 of 2 operational years, we can't discern the impact that seed year strength would have on as a potentially significant success modifier for regeneration in those plots. Again, more sampling over multiple years of different seed year strengths will be required in order to detect any difference there. So thank you very much for listening to this. I wanted to just point out a couple of people especially that have been very, very helpful in this process and in tolerating me. Dr. Patrick James, thank you for all your statistics support and last minute, sometimes very late chats regarding that. Adam for all of his advice this summer. Lakshmi for doing data collection, who is also a birthday girl today. So everyone wish her a happy birthday for that. All right, we don't have to do a group sing along, I guess, but and of course also to the entire forestry staff at Haliburton Forest and Wildlife Reserve, who were great. And of course, my awesome MFC classmates. Questions, preferably easy ones.
Hey, thank you, Callum. I'm going to pass the mic to Adam now to ask a question.
Thanks very much, Callum, and good job. I think I have 2 questions. The first one is, you mentioned seed years at the end there. Yep. Did you have a chance to check? I know we talked a little bit about this and you're having a hard time finding sources. Were you able to determine whether the years that you conducted the study or the years that the group openings were done were good or bad seed years for the species that you studied? Yeah, so lots of cold emailing. It's almost shocking that there isn't a lot of academic sources for that. So the consensus anyway, from what I've gotten, is that 2019 and 2021 were both good seed years for red oak and yellow birch, with 2020 being a rest year. And and this is verbatim from emails, black cherry in 2019 was fine, fine seed years. Like, okay. But that's about as specific as it gets. Yeah, okay, thanks. Yeah. And then second of all, you mentioned Jason Shabaga's email, paper at the beginning there.
Yep.
Did your results generally agree with what he found? And then a second part to that question is your results are obviously a kind of 2 years post-harvest. And I know Jason went 5 or 10 years post-harvest.
Right.
How do you think your results might either be similar or change as time goes on?
Yeah, I think one really important distinction to make here with, it's not really need to go back necessarily, but one important distinction to make with the Shibega study is that it found conditional success in fall harvested yellow birch sites. So I don't know if it's necessarily exactly comparable because he had seasonality comparisons. I don't know exactly how this is going to translate because, like you said, it was over a longer time frame, and I think with the data that I have pretty much agrees with Shibega's early results, like when he at the beginning of his sampling, fused a couple of years after harvest. But I don't know how this is going to translate in the long term. That's what you mean. If it follows the same trend, the block that we sampled was also a fall harvest. So hopefully we would see the same sort of success that he saw, that conditional success, but I think that's kind of time will only reveal that.
Thanks, Callum. That was great. Really interesting.
Okay.
Adam asked the best questions, so I'm gonna start to follow up on those a little bit. So, I mean, I of course really interested in this sort of cyclicity in the mast years and the seed years and what that means. So hypothetically, if you had perfect information about the frequency and timing of those good years, how would you use that information to guide the group opening approach?
Yeah, absolutely. I think that's one of the major sort of blind spots of this study, and it's just kind of had to be that way because I couldn't do over subsequent years. But ideally, if we were able to expand this data set to see performance of group openings over many seed years, that could potentially be a valuable management recommendation for forestry staff, only implementing group openings during strong or following a strong mast year. If that is found to be a significant factor in success of that group opening for the long term.
Would it be reasonable to think about scarification in synchrony with the masting?
As in scarification of the
Openings.
Okay. Well, they wouldn't be implementing scarification at a time other than when the harvest was actually taking place, right? Are you saying like in I think I can't think of any case where the strength of the seed year of red oak, for example, would impact whether you would implement scarification. Because if there's a few acorns, there's a lot of acorns, it doesn't change the fact that red oak prefers to have access to mineral soil. Is that what you're asking? Maybe I have an
Sort of. No, it's good. It's good. You covered it. And I don't want to take up too much time and let other people ask questions. So one other thought, you're very much focused on the seed tree within the group opening. Yeah. Was there any consideration of seed rain from trees in the adjacent forest rather than simply the focal tree within the opening? Yeah.
Again, this was just a really small snapshot of the results because it's a lot to fit into 15 minutes. I did actually, I think I have this graph. We did look at that. So this was whether or not there was a dominance of mature conspecifics in the plot boundary. And we did find that had a significant impact for black cherry and for red oak. So that is really, really interesting. And in fact, that probably also has some management implications as well that will be in the discussion, where even if you just retain a seed tree, there's probably also a significant modifier effect from whether or not there's a general dominance of that particular species in the surrounding area.
Yeah, and of course, I like that very much because that's very, landscape ecology, spatial context.
Yeah,
really matters. So, yeah, think about that more.
Okay.
Sorry to be asking. So there was a great presentation, really interesting. There's a older body of sort of management literature, I think particular to Algonquin, that had basically a story on group selection management that it's all about raspberry.
Yeah.
And the story is kind of that birch trees can hide in the raspberry, and therefore not get browsed. So I wonder if you see that kind of signal.
Again, anecdotally, yes. We also, I don't have the graphs, but we did do, as part of the data that we collected, we looked at percent coverage of different species, and it was raspberry and grass, which was the two dominant competitors in group openings. Anecdotally, that definitely seems to be the case, in that as I was scratching out my hands, peeling back raspberries, there was pretty much carpets of yellow birch regeneration underneath that. And again, anecdotally, maybe in the open areas that were in a rut where raspberries weren't growing, there wasn't that type of mat. So yeah, that is really interesting. Maybe that is hiding it from different large mammal browsing, for sure. Yeah.
Great. And I think we have time for one more question. Sorry, I'll just pass you the microphone.
Hi, you remember our international field trip to Central Europe?
Sure do.
Sure. The beach regeneration is always an issue also in Central Europe, although the boxes is not that much existing in Central Europe.
Right.
If you ask the foresters in Central Europe about the seed years of the beech, they will say it is about 5 to 7 years period.
Yeah.
For other species, it's not the same.
Right.
And with climate change, it becomes more and more random.
Yeah.
So like your answers to also Patrick's question, it is very complicated because you cannot really foresee when it will come to try to plan tactics, when and how to operate to make use of that.
Yeah.
So the foresters in practice, what they have developed is that to do a kind of assisted regeneration. So there is group felling in the beech forest over there. They do not want so much of the beech regeneration, but they prefer oak and fir species over there, and you have other species here. So what they do is that they come for tending to try to kill some of the beech regenerations and open space for others. And mainly because the seedlings and regeneration of other species is much more costly. Adam is here, you can ask him, how much does it cost to buy a seedling for cherry or for red oak instead of the beech? So it becomes a different story as well. Would you comment on that as well? Thank you.
Yeah, there's a lot of, I think there's a lot of ground to cover within that. I'm sort of, I can't really speak for the Haliburton forestry staff, but I think proposing that they go back and tend a lot of these sites is probably not going to get a lot of ground. I think that's probably a very European thing that may not translate well into North American forestry. But your point about at the beginning, if I understood that correctly, where beech are synchronizing or planning your operations also around beech mass steers, I think that's a really, really interesting point that I wish I could have done some analysis with if I had a larger data set. But not only is seed year of the target species important, but also seed year for other species that you don't want to be promoting in the group openings is also important. So it becomes sort of a complicated way of analyzing the interactions between those. That's really interesting. What else did you want me to comment on? I'm just trying to keep it. Well, no, it's really interesting. And I think if we're going to be developing pretty robust management recommendations, those are all things we need to consider. Yeah.
All right. That's great. Thank you so much, Callum. Really good work.